in this problem I've got a situation where I'm giving you the 3 side lengths of a triangle, and I'm asking you to find angle C using the law of cosines. Now, that's all you're doing, but I do want to talk about if I were solving the entire triangle, I would want to find angle C using the law of cosines before I switch to the law of sines for finding the other angles. And that's simply because I can tell C is going to be the biggest angle because it's opposite the biggest side. And so it's the only angle that might be obtuse. And cosine of an obtuse angle is negative, whereas cosine of an acute angle is positive. So the law of cosines can distinguish between an acute angle and an obtuse angle. Whereas with sine of an acute angle is positive, sine of an obtuse angle is also positive. So if I'm using law of sines, I can't tell the difference between an obtuse angle or an acute angle. So I want to know ahead of time, if I'm using law of sines, that I'm working preferably with an acute angle. So that's why I've sort of singled out C. All right, so we're going to find C. Again, we're going to round to the correct number of significant digits. I'm going to suggest that you pause the video, try this on your own, then tune back in and we'll work through it together. Welcome back. Okay, if I take a look, each one of these things has 3 significant digits. The only one that I have to really remember my rules for really is this one, a 0 to the right of the decimal, if it's not a leading 0. So if I have something like 0.003, those are to the right of the decimal, but they're the first digits that I have in my number. Those are never going to be significant. But if it's to the right of the decimal and there's a non-zero digit to its left, then it's definitely significant. So all of these have 3 significant digits. So when I find angle C, I will round to 3 significant digits. So that'll be whatever C is in degrees plus 1 more decimal point. So it'll be to the tenths of the degrees. Okay, so I'm going to use the version that singles out C. So that's C squared equals A squared plus B squared minus 2AB cosine of C. Now, since angle C is what I don't know, I think it makes sense to solve for cosine of C. So I'm going to just subtract these guys over. So C squared minus A squared minus B squared equals 2AB cosine of angle C. And then I can divide by, equals negative 2AB times cosine of C. And then I can divide both sides by negative 2AB. So cosine of C is going to equal C squared minus A squared minus B squared all over negative 2AB. Now that fraction has some arithmetic on the top and some arithmetic on the bottom. So I want to be very careful when I enter that into my calculator. Usually after I enter in the top, I just hit equal, so I have it do whatever was on the top. But if I want it to divide by this multiplication problem, I'm going to need to remember to put that in parentheses. Okay, so I like to write those parentheses when I copy it down on paper so that I don't forget them when I punch into the calculator. So cosine of C is going to be, let's see, C squared, that's 15.1 squared, minus A squared is 12.0 squared, minus B squared is 6.32 squared, that's in parentheses, all over negative 2 times A is 12.0 times B is 6.32. And all of that needs to be in parentheses so that we do this multiplication and then divide by the whole thing. Okay. So make sure your calculator is in degree mode. And let's do this. 15.1 squared minus 12.0 squared minus 6.32 squared. And I'm just going to hit equals. That way I didn't need parentheses, but I've done the arithmetic on top. Now I'm dividing by parentheses, negative 2 times 12.0 times 6.32, close parentheses. Then I'll hit my equal sign, And I get negative 0.29053, blah, 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 blah. Okay, not going to round that because that's cosine of C, and I wanted to know what C was. So C is arc cosine of that number. So on my calculator, I can hit shift and the cosine. That puts a net cosine inverse on my screen. And then I'm going to use that answer key to plug in that previous answer. And that gives me 106.88 blah, blah, blah. Okay. We were supposed to round to 3 significant digits. So remember, this only counts as 2, not because that 0 isn't significant. Under normal circumstances, a 0 between 2 non-zero digits would be significant, but because this is degrees. So this is 2 significant digits. This is my third. So since that's 5 or bigger, we're going to round up. So I would say this is approximately 106.9 degrees. Don't forget, you do need to include that degree sign.